Hi everyone, Assalamualaikum. In this video, we will discuss the possible steps to evaluate the integration of rational function. Okay. First, we do a long division from the given rational function. And after that, we express the rational function into the sum of partial fraction. And finally, we integrate using useful integration formulas or using U substitution or using inverse tangent. Right? Alright, we just do a long division only if the degree of numerator greater or equal to the degree of denominator. Okay? And after we do a long division, we need to write px over dx into the form of qx plus rx over dx. Qx here means the quotient and rx means remainder, right? We will discuss this qx plus rx over dx later, right? If the degree of px less than the degree of dx, means if the degree of numerator less than the degree of denominator, no need to do a long division. Okay, means we jump to step 2, right? Alright, when we express into the sum of partial fraction, we will have 3 types. Okay, first type, based on denominator here, we have denominator with distinct linear factors. Okay. Second type, denominator with irreducible quadratic factors. Irreducible quadratic factors means the quadratic function that cannot factorize. Okay. And the third type is denominator with repeated factors. Alright. And after that, we can integrate using useful integration formulas. Useful integration formulas means we use the formulas that will be given in appendix. Okay, which is formula number 1 for n not equals to -1 and n equals to -1. And we also can use formula number 15, which is inverse tangent, depends on the type of partial fraction, right? First, let's look at the long division of polynomial. Learning outcome. At the end of this session, the student should be able to divide the polynomial and write into the form of quotient plus remainder over divisor. Right now, we look at long division of polynomial. When we need to use long division? Alright, let's say we have integration of 2x to the power of 4 minus 7x squared plus 7x plus 1 over x plus 2 times x plus 1 squared dx, right? From this fraction or from this rational function, 2x to the power of 4 minus 7x squared plus 7x plus 1 over x plus 2 x minus 1 squared. We have numerator with degree 4. Okay? And if we expand the denominator, we have highest exponent equals to 3, means we have denominator with degree 3, right? This is called improper fraction. Improper fraction means the degree of the top is greater than or equal to the degree of the bottom, right? So this is improper fraction. So if we have improper fraction, we need long division, right? Means if the degree of the top is greater than or equal to the degree of the bottom. So it is called improper fraction and we need to use long division before we integrate, right? Alright, by doing long division, okay, we need to expand the factors in the polynomial function. Alright, so after we expand, so we get this. Okay, we need to arrange the indices in descending order. Okay, first we write x cubed and then x to the power of 1 and then constant. Okay, and then from the given fraction, we can write numerator inside division symbol and denominator outside division symbol. Okay, when we expand x plus 2 times x minus 1 squared, we get x cubed minus 3x plus 2 here. Okay, and then we need to put 0 for any missing term. Right? We need to arrange first x cubed and then x squared and then x and then constant. If we have x to the power of 4, so first we write x to the power of 4 and then x cubed, x squared, x and constant. Okay? If there are missing terms, so we need to put 0. Okay? And after that, we divide the first term inside division symbol. Okay, 2x to the power of 4. We divide by the first term outside division symbol. Okay, we divide 2x to the power of 4 over x cubed. Then we get 2x. Okay, so after that, we put 2x here. Okay, we arrange based on the same coefficient. Okay, we put on the top of 7x. Okay, we arrange based on the same coefficient. Okay, then we need to multiply 1 by 1. Okay, we multiply by 2x here. Okay, so after we multiply, we get this. Okay, multiply x cubed by 2x, we get 2x to the power of 4. And then 0x squared multiply by 2x, so we get 0x cubed. And then negative 3x times 2x, we get negative 6x squared. And then 2 times 2x, we get positive 4x. Okay, after that, we subtract. We must put bracket to avoid error. Okay, alright, so when we subtract, we have 0 here and 0 here. Negative 7x squared minus 6x squared. So means we get positive 6x squared minus 7x squared. So we get negative x squared. And then 7x minus 4x, we get positive 3x. Alright. After that, we bring down positive 1 here. Okay, so we get this. Okay. And then we can check the degree of the last row equals to 2. And the degree of the divisor equals to 3. Okay. So this is a remainder. Okay. This is a divisor. Okay. We stop the division when the degree of remainder less than the degree of divisor. Okay. Alright. So this is our quotient and this is dividend. Okay. Alright, so we can write the rational function equals to quotient plus remainder over divisor. Okay. So after that, we have quotient equals to 2x plus remainder equals to negative x squared plus 3x plus 1 over divisor. Okay. Divisor is x cubed minus 3x plus 2, which is equivalent to x plus 2 times x minus 1 squared. Alright. So from here, we have numerator with degree 2 and denominator with degree 3 if we expand. Okay. So this is proper fraction because the degree of the top is less than the degree of the bottom. Okay. So after this, we can express into the sum of partial fraction and then we can integrate. Right? Coming up next, more examples for long division of polynomials. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.